The Chernobyl nuclear power plant was named after Vladimir Ilyich Lenin. It was a flagship project for the Soviet Union. Construction started in the early 1970s. The plant was located in northern Ukraine, then part of the USSR. Its main purpose was to produce electricity, powering a large part of the region. Near the power plant, a new city was built, called Pripyat. Founded in 1970, Pripyat housed the plant workers and their families. It was considered a model Soviet city, with good schools, hospitals, and leisure facilities. The average age of its residents was very young, and life there was seen as desirable by many. The RBMK reactor design was a Soviet creation, different from reactors in Western countries. However, the RBMK design had known flaws, which could make it unstable under certain conditions. This set a dangerous stage. On April 25, 1986, a safety test was planned for reactor number 4. Its goal was to see if an emergency system worked, specifically, could the spinning turbines power cooling pumps during a shutdown. The test had been attempted before, but previous attempts were unsuccessful. This time, they hoped for a better outcome. The test was originally scheduled for the daytime shift. However, there was a delay. The regional electricity grid controller asked for a postponement because the reactor needed to keep supplying power, so the test was pushed back many hours and eventually began late at night. A new, less experienced night shift took over, and they were not fully briefed on the test procedures. As the test preparations continued, the reactor's power level was reduced, but it was reduced too much. Operators struggled to stabilize the reactor and needed to increase its power for the test. The conditions for a catastrophe were falling into place. The actual safety test began at 1:23 a.m. on April 26, 1986. The turbine was shut down as planned, starting the sequence of events. The flow of cooling water to the reactor decreased, and inside the reactor core, steam voids began to form rapidly. In an RBMK reactor, this leads to a power increase called a positive void coefficient. The power in reactor 4 started to surge uncontrollably. Operators saw the sudden power spike and tried to shut down the reactor. They pressed the AZ5 button, the emergency shutdown system meant to insert all control rods fully. However, the RBMK control rods had a design flaw. The tips of the rods were made of graphite, which briefly increased reactivity at the bottom of the core when inserted. This caused a massive final power surge. The disaster was underway. Section 4. The first hours, chaos and courage. Immediately after the explosions, confusion reigned. Plant workers were shocked and disoriented. The control room instruments gave contradictory readings. Some showed extremely high radiation, while others were off the scale or broken. Anatoly Dyatlov, the deputy chief engineer overseeing the test, initially refused to believe the reactor was destroyed. He ordered more water to be pumped into the non-existent core, which only worsened the situation. Firefighters were among the first to arrive. They came from Pripyat and the plant's own fire station. They saw the fires on the roof, but did not know the full extent of the radiation danger. Without proper protective gear for such a radioactive environment, they bravely battled the flames. Many of them received lethal doses of radiation within minutes. Their heroism came at a terrible personal cost, but they prevented fires from spreading to Reactor 3. Local officials and plant management were slow to grasp the disaster's true scale. There was a culture of secrecy and downplaying bad news. Section 5. A silent scourge, the lasting wounds. The environmental impact of Chernobyl was devastating and widespread. Radioactive isotopes were released into the atmosphere, including iodine-131, cesium-137, and strontium-90. The fallout contaminated vast areas of land and water. Ukraine, Belarus, and Russia were the most affected countries. However, radioactive clouds drifted across much of Europe, poisoning forests, rivers, and agricultural lands. The red forest near the plant died quickly. The human health consequences were severe. In the short term, plant workers and first responders suffered from acute radiation syndrome, or ARS. Over 130 people were confirmed with ARS, and dozens died within weeks or months from its effects. These individuals endured horrific suffering, highlighting the extreme dangers of uncontrolled radiation. Long-term health effects continue to be studied and debated. There was a significant increase in thyroid cancer, especially among those who were children at the time. They ingested radioactive iodine, often through contaminated milk. The psychological impact on survivors and displaced people has been profound. Section 6. A world awakened, confronting the fallout. The Soviet Union initially tried to conceal the accident. For 2 days, the world remained unaware. On April 28, 1986, workers at a nuclear plant in Sweden detected high radiation levels. They traced the source eastward. Other European countries also reported unusual radiation. International pressure began to build as governments demanded an explanation from Moscow. The secrecy could not be maintained against scientific evidence. Finally, the Soviet government made a brief announcement, admitting that an accident had occurred at Chernobyl. However, the full scale of the disaster was still downplayed. Mikhail Gorbachev, the Soviet leader, did not speak publicly about it for weeks. As more information emerged, global alarm grew. There was widespread criticism of the Soviet handling of the crisis, particularly the lack of transparency. This event severely damaged the Soviet Union's international reputation. Section 7. Echoes of Chernobyl lessons etched in time. Chernobyl taught the world hard lessons about reactor design. The RBMK's inherent instability was a critical factor. The importance of robust safety systems became undeniable. Containment structures lacking at Chernobyl were re-emphasized. The accident also highlighted the crucial role of human operators. Proper training, clear procedures, and a strong safety culture are essential. Technology alone cannot prevent disasters if human factors are ignored. The disaster exposed the profound dangers of government secrecy. The Soviet Union's initial silence worsened the crisis. It delayed evacuations and protective measures, sowing mistrust both domestically and internationally. Open communication and transparency are vital during any emergency, especially for incidents with cross-border implications. Chernobyl became a powerful